Morning, good afternoon, or good evening, depending on where you're joining us from. Welcome to another DevToberfest session. Continuing the topic for today's Thursday, it's a Mad Thursday, machine learning, AI, and data. So, keeping with that trend, we have another exciting presentation today on choosing the right large language model for your use case. Accuracy, cost, and performance in the balance. So I want to welcome our two presenters, and with no further ado, I'll just turn over to both of you. Looking forward to this session. Have a great session. I'll be back later to help out with the questions.
Thank you, Thomas. So, hello, community. It's us. It's Joerg, Goeppert from SAP.
And my name is Tatt, also from SAP.
Okay. As Thomas said, it's about choosing the right LLM for your specific use case. And what we show you is it's what we experienced about our project. What we saw is we bring you kind of subjective view on what we achieved and what we saw, and we try to inspire you. And but be aware and remind it's an internal tool we are showing, so that's why have a look at the disclaimer. And
Yeah, don't worry, we're not going to read you the disclaimer.
shouldn't do so. Okay, perfect. So as said, we are from SAP Design. We're the products concepts team. Means we're a set of designers and developers who are very multidisciplinary team. We have complement teams skill set, and therefore we try to achieve really end-to-end experience. And our focus on design and of course on the developer side is to really have to focus on customers and the users. So it's that's why we'll hopefully find out later that they are really the key. What we are doing is about them. We are creating kind of proof of concepts, prototypes. We explore new technologies, new ideas we have, try to leverage SAP technology as far as we can get, but if not possible, we try and find other stuff as well. So we might not be the experts in what we do, and we seldomly are, but we do not have a kind of, we fear to make our hands dirty. We try to go into new topics. And yeah, that anything to add on that one?
Not really, we just wanted to share our experiences and maybe inspire you to do some experimentation yourself.
Thanks.
Okay. We would like to talk about one of the prototypes that we built in our team. The basic idea behind this prototype was to use AI to help developers work better in their daily work. No, sorry, the designers. Why designers? Because design is our home turf. And if you're familiar with SAP and UI, you might be familiar with the SAP Fiori design system. It is SAP's design system, just like the human interface design from Apple. And the idea is that we want to allow designers to consume the contents of this design system easily. All the documentation is hosted on the website on the about the design system. So we would like to bring this information to the designers. We did this in two ways. One is that we embedded an AI assistant directly onto the Fury Guidelines website so that you can go to the website and ask questions. And the second way was to bring this into Figma. Why Figma? Because it is the natural home of where designers do their daily work. So we decided to bring this as a Figma plugin as well.
And we thought, besides that, we show the things there what the people really needed. It's an additional chance to get feedback from the community and for our own experience to start using AI and to feel what it can do and where the constraints, and have a project that brings ourselves up in the knowledge of AI and helping our community to kind of focus on their need and to work with their tools. So we might now show you the demo. So we will show you now here a Joule kind of thing, digital assistants integrated as a plugin into Figma. The good thing about that one is that if you just have a chatbot and you have to describe what you're doing. So now I'm creating a UI with SAP Fiori And I now embed, for example, let's say a message toast into my stuff. And on that message toast, I have a question. As we can now grab really the context of the application, we can now just select kind of the message toast. You see, it says anything about a message toast. So the context is now the message toast. And if you want for something to want to know how long it's visible on the UI, I can now try to ask the system and hopefully get some useful results about that one. Take some time, and of course you see, okay, it found something. There is no exact value, but it says it's some seconds, and you can tune it if you want to. The good thing about our tool is now you see the document sources where we found the information, and you see it's matching what we asked for. And besides that, we can now have the possibility to really give feedback to what you see and to try to get information from the user group, the target user group. Yeah. So the thing, what you saw is, as you might see, as a RAG, is a retrieval augmented generation. So how does it work? So basically, we took the Fiori guidelines, processed the data, meaning we chunked it into smaller pieces. We then calculated the embeddings, so the vectors behind that one, and store everything in the SAP HANA vector engine, so in our database. And based on that data, we now, if a user asks for this question, for example, regarding the message toast, we take this question, then we see whether we have already some chat history, so there are already things there. If it's there, we try to refine the question to include the current asked question with the context that was there before. And from what we then get as a refined question, we then ask the vector engine to retrieve us documents that fit exactly the meaning of the topic you're asking for. So that's done in the SAP HANA database set. The result we get from the vector engine is taken as one input into the LLM. And of course, there is a prompt that is a kind of prompt engineering stuff around it. It's the information, so it's the influential referential documents. We put that one in the LLM and let the system answer. And to be able to show the kind of the metadata of the documents that we shared and we found, we also have some additional metadata in addition to the answer shown to the user laterly. The thing on how this vector engine is really working and what it really means, will Tatt explain now?
Yep. Like Joerg mentioned the use of the vector store. We use the vector store to retrieve the documents in order to answer the user's questions, right? And it is a little bit different from a classical text search because we are not searching based on character similarities or the similarity of a string, but we do a search based on the semantic similarity, meaning they have its own. We retrieve the documents based on the meaning of the text and not if the characters are similar. And one of the algorithms that allows us to do this is called the cosine similarity. We have an example here. Let's say the user asks the question, what is the preferred color for UI buttons? And then we have two answers. The first answer is users like blue colors for active buttons. It has a very high similarity to the question, in this case 0.8, because we are both talking about buttons in a UI, right? Active buttons in the UI. And the second answer says, I love green buttons on my jackets. It also talks about buttons, but it's buttons on a jacket. So you see that they have the same word, same characters, button and button, but the vector store understands that it is a different semantic, it has a different semantic meaning to the question. Hence, it has a smaller cosine similarity.
So, and why we thought LLM is the right thing and the RAG is the right thing to use for our use case. And that's to say, okay, you can of course take the guidelines homepage and navigate through it and jump to the deeply nested hierarchy and do whatever stuff you do and do some text search. But besides that, if you say, okay, now we have kind of digital assistants using RAG technology, it's more, you can talk in the language you want to do. It's a kind of your natural language. It's not limiting you down to a specific set of terminology that was used in the documentation, but you can, as just shown by Tatt, you can talk about the thing and the system mostly understands what you really want to talk about and then gets the relevant documents out of that and then uses it. So meaning it's really you're interacting with the data instead of just parsing, linking, hopping through the different documents. And of course, this was the idea why we used it. And yeah, the sheer amount of pages that you might need to know to get a complete picture of the design system is then of course gone if you have to really to be able to answer your questions at the decision point where you are now. Meaning, for example, in the Figma plugin.
Yep. And like you all mentioned, we use the natural language. It is not only on the user side where they can ask questions in natural language, but it's also for us developers because we engineer the prompts. So it's also very exciting for us to implement this because we are no longer dealing with traditional coding, but you're actually talking to the LLMs. And because we are at SAP, we have the luxury of using the SAP Generative AI Hub. The Generative AI Hub is basically a solution from SAP that allows applications to configure and access multiple LLMs from different providers. It's very easy to use. You just configure which large language model you want to use, and then you can use it from your application. And you can also use multiple models in the same application. So at this stage, we had a problem. I mean, a problem because we had so many models to choose from. So we needed to boil this down into a short list and evaluate which model that we really wanted to use. And these are the four models in our short list that we evaluated. The first one is the most famous, I would say, from OpenAI, GPT-4o. Then from Google, Gemini 1.5 Flash. And then also another big player, Anthropic, Cloud 3 Sonnet. And then a open source model from Mistral, the 8x7b. So we started work on evaluating these models to find out what is the best model to use in our use case.
As already said, as the center for what we are doing is the user and is our customers, internal, external customers, said, okay, it's not on us to decide what's the best answer. So we need to find criteria on which we decide on. And we came up with these three dimensions. It's accuracy, cost, and performance. Accuracy, it's about the quality. And quality has, in our case, two different meanings. In the one, of course, it needs to be the correct answer. And next to it, it's also is the answer in a way and in a style and a form that they really can use it. And is it in granularity that's fitting? Is it too less or too much or what to do? So that's what the thing we'd like to let our users answer the question or select the best matching LLM. On the case cost level, it's of course there are different costs. We can't. It's depending on your setup, but as we see later on, the cost is mainly driven by the number of tokens you are using, so the data that goes into the LLM and goes out of it. And of course, per token, you have a specific cost per model. And you multiply and you get the result out of it. And of course, performance, every user wants to have fast and milliseconds, whatever. That's a bit hard on LLMs. It's not on sub-seconds or rarely on sub-seconds. But what you get is now kind of three different dimensions. At least that's what we used. And to figure out what's the best balance and the right balance and which system or which LLM is then the one to be chosen in the real world in our kind of productive landscape.
So now let's talk about the first criteria, accuracy.
So, yeah, as we do not have the knowledge on our own, we said, yeah, let's let our users decide. And there are now a kind of a group of people that are willing to kind of give us the feedback. And it consisted mainly out of two groups. One are the community, it's the user group, the target audience that uses the tool at the end. And of course, they have the opinion on, does this help in my situation? Do I like the feedback, the answer, the style of it? Is it enough to understand? Are the imaging correct? How does it look like? And on the other hand side, there are the experts, so the ones that created the guidelines, and they're the one they can judge if it's really correct what the answer gives. You know, it's LLM. They always sound very confident and convincing in what they're telling you, but basically you have to either believe or not. And that's why we had our group of experts that helped us to vote the best answer on a really quality, on the correctness, not only on the style of answering.
Mm.
So, and of course, we we should, or we had to give the opportunity to the user to select the answer that best fit. And then, of course, we can then analyze and see what's coming out of it and interpret the results and visualize them. So, Tatt, you want to take over?
Yep. So one of the ways that we collected the feedback is that we took the same question from the user and then we called the same question on 4 different LLMs that we want to evaluate. And we show all the 4 answers to the user. But the most important thing here is that we do not show the name of the LLM. So the user sees 4 answers, they do not know which LLM presents the answer, and they get to pick the best answer from these 4. And what we do is that we record this decision from the user as a feedback in our database so that we can analyze this later. Of course, everything is anonymized and we can't track who's doing what, but basically we track which question and which answer was chosen as the best answer.
And by that, we track what was response time of the LLM and what was the number of tokens that was used. And to also not bias people, the order of the answers was kind
Yes.
of randomized.
Yep.
We see here now the basic request flow we did. So we saw the diagram before already. It's basically starting the same. And the important part is that we have still the user question. If there is a chat history, we find the question. We get the documents from the vector engine. And what we get here is the same input for all of the 4 LLMs. So they cannot have different inputs. It's exactly the same input, the same questions. So it's the possibility to have really run them in parallel. We are weighting all of them. We collect the statistics behind that one, display all of them to the user, and the user then can really select the best answer they think for this question.
Mm.
And then we store the best voted answer. And we said you could say you have 4 different ones, then give us the order in which you think it's the best. But on the one hand side, it's time costly for the user, and of course, distinguish the best one might be easy, but if then to select the second, third, and fourth best takes time, and it's not really clear whether you really have that difference to show and to make. So what we get here is now the answer of, or the statistics of the answering of the people. And you see LLM from ChatGPT, the GPT-4o is the one that is rated best in the community and in the expert group. But what you also see is that on the position 2, 3, and 4, it's kind of the opposite what you get. So see that Gemini, for example, is the community is least best, but in the experts rated quite high. So second best after the LLM. Sorry, after GPT-4o. So that's something we might come later on in the one or the other slide as well. But this was the pure result from the checking the best answers that people selected in the demo in the tool.
Mm-hmm. Okay, so up to this point, you learned that the user has selected the best answer, right? But what about answer number 2, 3, and 4? It would be also interesting to see which of the other answers are rated second, third, and fourth. And at this point, we had the idea to use LLMs to decide the positions 2, 3, and 4. So the idea was that the human user chooses what's the best, and the LLM chooses what is second, third, and fourth best. The idea here is to use LLMs as an evaluator to evaluate the answers from LLMs. And This is kind of obvious, but since we are building solutions for human users, the human preference is always the golden standard. You want to always keep the human preference in mind when evaluating LLMs. But we can also use LLMs to evaluate LLMs as well. In addition to that, this has a bunch of advantages. For example, it is scalable. I can ask an LLM to evaluate 10 answers, 10,000 answers, and it will just scale. The second is that it is more consistent. The LLM doesn't need to have a coffee break after 5 hours or 6 hours, and it doesn't become tired with time.
By the way.
Cheers. And it is also cheaper than having humans as evaluators because the LLM call also costs money, but it is always way cheaper than the human wages, for example. Now we have a fun fact here. There was a study called the multi-turn benchmark, and they found out that GPT-4 has an 80% agreement rate with human preferences. So the humans and GPT-4 agree 80% of the time on what is the best. And the super interesting point here is that 80% is also the agreement rate between humans. Let's say you and I decide on something, we also have a 80% agreement rate. So it's like very close to human preferences.
Okay, so we said now we had our small little dedicated prototype that got the results, and as Tatt said, we just try to get the second, third, and the fourth best. But as an additional source of data, we said, yeah, you saw before you can have the thumbs feedback in our application, so in the plugin. And whatever feedback we collected before, we said, okay, now we have a solution that was really high rated. So we took the highest rated answers from the history, from the feedback that was given, and used that one as input for this LLM rating, LLM thing. So a meta LLM rating based on the golden standard the user selected in the best rated feedback that were given.
Yeah. So there's some details about how the evaluator that we built actually works. They have a bunch of inputs and then you have the output. So let's start with the input side. The first input is the user question. This is the questions that we collect when the user uses our solution. We record the question. And then the second input is the reference answer, which is the answer that has been picked by the user as a good or great answer. And then the third input is the list of LLMs that we want to evaluate. How this works is that our solution goes ahead and goes through the list of LLMs and then feeds these LLMs with the same user question, generates the answer. So in this case, it will be 4 answers. And then it will compare each of these generated answers with the reference answer that was chosen by the user. So as you can see up to now, we are using LLM as an evaluator, but we are still keeping the human preference in the loop, which is very important. So what is the output of our evaluation? The output has three important parts. One is the ranking. It tells us which LLM is ranked the best, second best, third, and the fourth, right? And then the second is the so-called rating. The rating is something that we decided to use as a secondary metric. What it does is that it provides you a number of 1 to 10. So if the number is 10, it means that the answer is matching the reference answer 100%. And as it goes down, maybe you have that a rating of 6, it means that the generated answer only is 60% of the quality of your reference answer. So using this rating, we can not only see which is the best, but how far the second and third best is from the best. It's like, you can see the distance as well. And the third metric that we have generated using this evaluator is the reason. We also record why the LLM has decided something is the best or the second best. So maybe let's say LLMC, it could say that, okay, I'm rating this 6 because it is matching the reference answer on these parameters, but there are certain aspects of the answer that has been left out by LLMC. And just like humans as evaluators, when I'm evaluating something, when Joerg is evaluating something, we always have our personal bias, right? As individuals. So LLMs, we also interestingly observe this in our evaluations as well. And then we started to read about this in literature, and we found out that it is quite common that LLMs have these biases. So these are the biases that we have found, and also the ways that we mitigate these biases. The first bias is called self-enhancement bias, which is that the LLM prefers its own answer. Like GPT-4 will prefer answers generated by GPT-4. Just like, let's say I would prefer answer generated by me and not York.
Hey.
And the way to mitigate this is that we use multiple evaluators and then compare the results. The second is verbosity bias, which means that the LLM prefers longer answers than shorter answers. And we use prompt engineering to mitigate this by saying, don't care about the length of the answer, just focus on the quality of the answer. The third is position and an input array bias. It is, let's say you give an input of four answers, certain LLMs will prefer input number two, input number three. So in order to mitigate this, we would randomize the inputs by using a shuffling algorithm before we put the inputs in.
And what you see here now is you have two colors here, meaning that's the blue color means that's the rating GPT-4o got or brought as an evaluator, and green is the one that's Claude 3 Sonnet did. And what we thought, of course, Claude likes his own answers a bit more than GPT, but still, even Claude recognizes that the best quality of the answer seems to be the GPT-4o answer. So that's a bit surprising, but still you see a slightly difference in between them, but it's still true. It looks like GPT-4o is the winner on that one. You see on the right side that Gemini is very, very small, and there's a reason behind that. So we thought about it, hey, why? And you saw that the experts rated it quite good compared to the others. And what we then saw, and that's maybe got to this verbosity thing. Of course, if you have just one or two sentences giving you an answer and you've compared this one to 2 pages of text that was returned by another LLM, something is missing. And of course, this means the LLM could think that some important stuff was taken over, taken out or forgotten. And that's why we think it goes a bit down. But at the end, it might be user preference, if it's short and precise, is fulfilling the need or not. So that's why we think Gemini is better than it looks like on that screen. So that's the result of that, or our interpretation of the story.
We move on to the second aspect, which is cost. The LLMs, the cost of an individual LLM call depends on the number of tokens. The number of tokens is basically how many words that you key in your prompt and how many words you get out of the prompt. This is done based on a token basis. And what are tokens? Tokens are groups of characters that often occur together. So the LLM would break the sentences down into tokens and then use them to calculate the cost.
So there is a number of a rule of thumbs that about 4 characters makes in the English language makes 1 token. So that's some kind of average rule of thumbs. And you see in German, it's a bit strange. We are concatenating all the different words and get a huge word out of it. And as you can see, it's much more than just one. So it even has, I think it's 9 tokens compared to complete English sentence. So that's the funny part of it.
Nope. And the cost of one LLM call depends on a few things. One is the number of tokens, so how many tokens are generated. It also depends on which that you use. The open source models will be cheaper. And the third aspect is that where your models are actually hosted.
As we can see now, and that's something that's also related to the thing we just discussed before. You see that Gemini got a real smaller number of tokens compared to the other ones. So GPT-4 and Claude and Mistral are kind of the same number of tokens, but Gemini is really much less than that one. And of course, one reason is that we used Gemini 1.5 Flash. That's designed to be a bit more flashy. No, it's faster and more precise, and so there's always a pro and a con, and yeah.
This is the relative average cost. We don't show you the cost here in euros or dollars because it's always dependent on which infrastructure you're running your course on. So we are showing only the relative cost. You see that GPT-4 and Claude 3 are quite expensive, and Mistral and Gemini are cheap, but they're cheap for different reasons. Maybe Joerg can tell us why they're cheap for different reasons.
Yes. As we just talked before, but on Gemini, it's because the number of tokens is quite small compared to the other ones. The price itself is kind of similar, but it's a small number of tokens that is delivered. On Mistral, on the other side, it's the same number of tokens, but of course the cost per token is much smaller. It's an open source model. It's hosted internally in SAP system, so it's cheaper on that end, but it's only one part of the game.
Yeah. Now moving to the third aspect, performance. This is quite straightforward. We measure the time that is needed to answer the question. We see that the first three, GPT, Claude, and Mistral, are quite slow in the response time, and Gemini is the fastest. This also could be the same reason like York mentioned, because the responses are faster because they are smaller on the Gemini side. Okay, so we have measured these three different criteria. What do we do with the results? We need to bring them back together, right? And these are how we visualize the all three aspects brought back together. And let's look at cost first. We see that Gemini and Mistral are way ahead on cost because they're the cheapest, and GPT-4 and Claude are more expensive, but close to each other. We see that from a performance aspect, Gemini is the fastest, and the three others are close to each other. But the most important criteria for us is accuracy, because we are building this solution for knowledge workers, so they have to be really accurate in the answers.
Yeah, one addition to it is Gemini might be right in what it tells, but as it's not that much of information, it's kind of still a bit depending on who you are and if it fits your needs. So it's not saying that the accuracy of Gemini is small. It's very short and precise. And for the one or the other, it might be too less information to really get into it and to maybe learn from it. That's why we think the outcome is a bit against Gemini, although it might be correct in all of the answers.
And based on these three criteria, we decided to use GPT-4o because the accuracy is the best. And we know that from a cost and performance perspective, it is not the best, but it's still within the boundaries of what we deem to be okay. And it's not that far behind the other three models. So we decided to use GPT-4o.
But as you see now on our key learning slide, there is no one size fits all. So each and every LLM has their good parts and the not that good parts, that they are better suited for the one or the other use case. And that's why one of our learnings is in your use case, try different LLMs and check what's your criteria to make the decision on which one. Take many of them, go to the AI Launchpad and then test them out and compare the results, ask your users, and then use them where they are suited. And even with our new project that's working now currently, we use different LLMs because there are different tasks within the complete end-to-end process. And for the one is better, and for the other, another one might be the better one.
And the second point is quality in, quality out, because the answers that the LLMs can provide can be only as good as your data quality. So you make sure that you train it based on or use a correct and good data set to answer the questions, and also be aware of how you access the data.
Yeah, and as I said, it's the user at the end that consumes information, and you should focus on the needs of your user, and that also might depend on your situation. And be aware that there might be different user groups, as in our example, the experts in the community that might have different preferences, and you might need a way to use prompt engineering to fit or make the answer fitting kind of the one or the other group, or in a way both can do, or yeah. So there are different ways of prompt engineering, as you know. Try it out.
So our last key learning is keep exploring, because even though you have an idea to use an LLM in the beginning for your main use case, you will always be able to discover new ways of using LLMs in your use case as you go along. For example, we had the idea of using LLM as an evaluator later on, and just keep on trying, and you might be surprised by what you could find. So
I think now kind of at the end of the presentation or the thing we want to show to you. So thank you for listening. And if you want to contact us, feel free to do it via the communitysub.com. We'll look at that one. And now opening up for your questions that might have been in the queue.
Yeah, we do have two questions waiting, but first I just want to say thank you for sharing your experiences and your own research, valuable to others that are going to use it in similar or even very different ways, but use cases, but still useful to see the process that you went through. But let's jump in here with one of the questions. It's from a little bit ago. The user asked, was GPT 4.0 compared with Claude 3.5 Sonnet or with 3?
3.5 Sonnet.
Okay. So 3.5 Sonnet was what it was compared to. And then the same user had what was maybe a follow-up question here. And they were kind of pondering, was this kind of comparing apples to oranges? And he went on to clarify, if targeting accuracy, a comparison between 4.0, Claude 3.5 Sonnet, Gemini 1.5 Pro would be really interesting.
Hmm.
That's as we said, we might even go to one slide where we did kind of what's the user preference, and we know that every provider or most of the providers have a different LLMs to use, and of course we could have thought, yeah, it's more fair to say let's use the 3.5 Claude 3.0 Opus, the most expensive Anthropic one compared to the latest GPT 4.0. Or go the other way and say, let's use some GPT 3.5 turbos via the Flash.
Hmm.
So that's a different axis. And of course, it's in the best of our worlds, we would have asked 20 models in parallel and then analyze it. But as a lack of time and implementation capacity, we chose those. And of course, it's not pro or against one provider. It's also a bit of the style and the natural behavior of different LLMs. So it's a kind of apples and pears, but still it's also a thing we want to find out. And as now Tatt shows here the slides, it's as even our own little research showed that experts tend to more value short and concise answers. So they know already most of it and they want to have a precise answer. But if you're a beginner and you are not that deep into a topic, it might be not enough to get an answer like, yes, it does, but you need to know why and to get the context around it. And for those, it might be of interest to get more details. And of course, you can say, when I start, please try to be concise and precise. And if I need more information, I follow up because it still is a chat. And we have a chat history on that one. So
Yeah, and it's a good point from your that, and also the question that different models have different pros and cons, right? And you could also imagine using multiple models in the same use case. So depending on the task, you might switch up the models depending on what answers you need and the criteria.
or have a user parameter saying, hey, I want it really precise, and then you might ask
Yeah.
Gemini. Or you'd use prompt engineering to tweak the answers, because we once asked GPT-4o if it thinks itself has very short answers or very, very wordy answers, and it says kind of five. And it also says, I'm an AI, tell me how I should behave.
Yeah.
And that's the point. I think all of them can be very precise and can be very wordy. It's just that the natural character that makes them answering in the one or the other.
Yeah. And on this point, you actually had a very cool idea. He used LLMs to decide what is the user profile. For example, if you're asking questions regarding mobile applications, you could be a mobile developer. So based on the user profile, you could then use the LLM to decide who is the user and then decide which model to use in the query or dynamically. this is one way of how we could use it.
So that's often a kind of thinking, why not using LLM to answer questions we also do not really have an answer for? Let's try the LLM do it. Yeah. At the end, it's a big playground. This I also say I talk it at least for us at the moment, it feels very, very interesting, many different ideas, and yeah, it's fun.
Yeah. Good. And the person that posted that question says thanks, and that they really like the LLM as about evaluator showcase.
Yeah,
All right.
we have some very interesting figures where you see, and that we do not even understand the images on our own because it's that complicated of the elevator doing the other one. But okay, we made it.
Yeah. Good. Good. There's no further questions right now, but if anybody else has a question, then please ask it in the chat. Maybe just give everyone a moment to decide on a question. Just a little housekeeping in that we still have, I believe, 2 more sessions in MAD, our Machine Learning, AI, and Data Thursday. And of course, tomorrow, Friday, the last day of educational content in Devtoberfest, it'll be our front end Friday. So we'll have more UI related sessions, as well as a fun Friday activity. We're celebrating Halloween a little bit early and doing a Spooktoberfest Friday, where we'll have you'll have the chance to earn some bonus points in the contest by posting pictures of your Halloween decorations, a Halloween costume, or even maybe the scariest bit of code you've ever seen while working. I'm sure we've all ran across some scary code from time to time. Hopefully, you're not telling on yourself and posting code that you wrote, but a coworker. And then, speaking of the contest, keep in mind it runs through Sunday night, so it goes till midnight U.S. Pacific time on Sunday. So end of the day Sunday. So you still have some time. If you're real close to that Nerdvana level, the fourth level of the contest, there's still time to complete some tutorials, watch some sessions, whatever it takes to get those last few points. And you want to do that to qualify for the grand prize drawing, which is a trip to next year's in-person Tech Ed experience. We haven't announced where that is yet, but we already know we're going to give away prizes to send people to that event. All right. I don't see any other questions in the chat right now, so I assume everybody's had their questions answered. You can always post additional questions in the description of this video or go on to the community event entry for this session. Post your questions in either place. We'll get them back to the original presenters to ask or to answer those questions for you. But if there's nothing further, then go ahead and wrap up this session. I want to thank our presenters for coming on and sharing their time and their experience and their use case in particular in this scenario. It kind of opened my mind of other things that we could use LLMs to test themselves on. It's pretty interesting way to go about using them. A little bit of a potential Mobius loop there as they evaluate themselves. But yeah, that's interesting stuff. So thanks so much for adding your content to this year's Devtoberfest.
Thank you
Thank
for
you.
hosting us. Thank you, Thomas.
All right, and until next time, enjoy the rest of Devtoberfest, and hopefully we'll see you out there on the Tech Ed on Tour events and in the coming weeks as well. So until then, thanks a lot, everybody.
Bye.
Bye.
All right, the stream is ended. Oh, they dropped.